Today we're going to look at odds and expected value, which are applications in probability. Here's our problem. In the game of Splodge, a player pays $3 to spin the spinner. If the spinner lands on a consonant, the player receives $1. If the spinner lands on a vowel, the player receives $7. A. What is the probability of the spinner landing on a vowel? B. What are the odds against the spinner landing on a vowel? And C. What is the expected value for a player who plays many times? Let's consider part A. What is the probability of the spinner landing on a vowel? Since there are 2 vowels out of the 7 letters in the word splodge, the probability of the spinner landing on a vowel, which we can call P of V, is 2/7. Now consider part B. What are the odds against the spinner landing on a vowel? The odds against event V occurring are the probability of the complement of V divided by the probability of V. The numerator can be written as 1 minus the probability of V, or 1 minus 2/7. The fraction simplifies to 5/7 divided by 2/7, or 5/2. Thus the odds against the spinner landing on a vowel are 5 to 2. Notice that we don't really need to use the formula to find the odds. Since there are 5 non-vowels and 2 vowels, the odds against spinning a vowel are 5 to 2. Now let's consider part C. What is the expected value for a player who plays many times? To find the expected value, find the sum of the products of the probabilities and their expected payoffs. Our player will pay $3 to spin the spinner. If the spinner lands on a consonant, which has a probability of 5/7, the player will only receive $1 back, so the payoff will be -$2. If the spinner lands on a vowel, which has the probability of 2/7, the player will receive $7, so the payoff will be $4. Thus, the expected value E is E equal 5/7 times -2 plus 2/7 times 4. This simplifies to -10/7 plus 8/7, or -2/7. Rounding to the nearest cent, that gives us -29 cents. It's important to realize that the expected value cannot be used to determine the outcome of any single experiment. Our player could never lose 29 cents on a single spin. Expected value is an average of winnings over the long run. Since the expected value is not 0, this is not a fair game, and our player would be better off not playing the game of Splodge.